it. We proved it. Okay, so here we go. What?
It's Friday.
Okay, so in section 9.3, we're going to talk about the integral test and we're going to talk about the P-series test. And I don't know if we'll get to P-series or not. We didn't get very far in third.
Have we done some P-series before?
Yes, we have. A P-series is 1 over x squared, 1 over x cubed. It's all that stuff that y'all just told me you didn't like. It's coming back, so get ready. Okay, integral test. If f is a positive, continuous, and decreasing, if f, take out that a. If f is positive, continuous, and decreasing, for x greater than or equal to 1, and a sub n equals f of x, then the series from n equals 1 to infinity of a sub n if f is positive, continuous, and decreasing for all x greater than or equal to 1, and a sub n equals f of x, then the series from n equals 1 to infinity of a sub n and the integral from 1 to infinity of f of x dx either both converge or both diverge because of the reasons that we've been beating like a dead horse for the past 20 minutes. Yes, sir.
Why does it have to start at 1 and not at 0 or something?
Because the fact that the y-axis might be a vertical asymptote. Okay, and generally these, remember, the values of n are the positive integers. We usually start at 1. Okay. All right. So let's do a couple of examples. Determine whether the series converges or diverges, and we've got 2 to look at. Determine whether the series converges or diverges. So we have the series from n equals 1 to infinity of n over n squared plus 1. So what's the first test we're always going to look to try? The nth term test, right? Because that one's so easy. If it doesn't go to 0, boom, I'm done, it diverges. Okay? It goes to 0, right? I do the nth term test, I do the limit as n goes to infinity, it goes to 0. What do I know? I know nothing at this point, right? I know nothing about that series, okay? I know that it could converge. There we go. That's what I know. All right? Is it geometric? No, it is not. And you have only learned one other test. I just taught it to you, and it is the integral test. So I should probably try that one, right? Okay, so I'm going to take this series, and we're going to rewrite this series as a function, and I'm going to do the integral of that function. Okay, so essentially what you're doing is f of x is now x over x squared plus 1. And you don't have to write that every time you do a problem. I'm just writing it for this first one so that we can apply the definition. Now, I do have to verify those three things in order to use the integral test, right? I have to verify that it is positive, right? For n greater than 1, because that's where it started, will this be positive?
Yes.
Yes, check. Is it continuous? Is there any value where with x being greater than 1 where this will be not continuous?
No.
Nope, so I'm good. Is it decreasing? How do I know that? The denominator is bigger than the numerator, right? How could you verify that if AP asked you to show it, or if you got to one where you couldn't tell? Take the derivative. If the derivative is always negative, right? Or does it doesn't have to be always negative. If the derivative is negative at any value where x is greater than 1, then it would not be then it would always be decreasing and you would be good. Okay, so you could always verify whether it's decreasing by taking the derivative. Yes, sir?
You would take the derivative like that.
I would take the derivative. Yeah, let's just take it real quick. So f prime of x is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared, right? That simplifies to give me negative x squared plus 1 over x squared plus 1 squared. The denominator will always be positive, and the numerator will be negative as long as x is greater than 1. So will it be decreasing?
Yes.
Yes. Okay.
It doesn't have to be greater than 1 though, right? Because it's everything's squared, so it's gonna make it.
Well, if it was like 0.5, it would give you a negative number on or it would give you a positive number on the top, which is not what you want.
Yeah, but we just use integer values, so, okay? All right, so I'm good. I check out. So now I can actually do the integral, right? Because it's what the integral does that determines what my series is going to do. So I know it's going to be improper, so if it's okay with you, I'll go ahead and set it up that way. I'll say the limit is b goes to infinity of the integral from 1 to b of x over x squared plus 1 dx.
Yeah, do I equals y?
No, ma'am, you do not. Okay, so all I did was take this series, convert it to this integral. All right, so how are we going to integrate? U substitution, right? What do you want to let u be?
X squared plus 1.
X squared plus 1, which means du is
2x dx.
2x dx. So I've got the limit as b goes to infinity. Let's go ahead and convert my limits of integration so I can keep it easy. U of 1 is 2, and u of b is still going to be infinity, right? So I'm going to go from 2 to b. I'm going to have a u on the bottom and a du in the numerator, and what else do I need? A 1/2.
Do you have to continuously write the limit as b approaches infinity, or can you just like put an equal sign?
As long as you have it at least once. I mean, theoretically, you should carry it with you. You at least have it once.
Do we have to do substitution?
Not if you know it. And not, you just got to make sure you have the 1/2. Okay.
Isn't it x plus 1, so it's x over x plus 1, not 1 over x squared plus 1. Never mind.
Okay. All right. So then this integrates to give me what? Right. ln of u from 2 to b. So I have limit as b goes to infinity, 1/2 ln b minus 1/2 ln 2. Well, if b is going to go toward infinity, what's this whole thing going to go toward? Infinity, right? Which means what? Therefore, the series from n equals 1 to infinity of n over n squared plus 1 diverges. So for every n that you substitute in, right, you add all those numbers together, it's going to continue to grow without bound. Right, Timothy? Because you said that's how you kind of think about it, is plugging in those values of n. So what we're saying here is for when I keep plugging in the n values as they increase, this term is just going to continue. I'm going to keep adding to it.
Do you want us to put divergence by the integral test?
Well, I've pretty much shown that by all that. You could if you wanted.
You can be like, well, you did write down because of the integral test. Nice.
They might.
True that. Okay, so let's do number 2. Series from n equals 1 to infinity of 1 over n squared plus 1. Okay, thank you. Inverse. Okay, so I'm going to write this as an improper integral, right? That's what I need to do is, if I do the nth term test, it gives me what? 0, right? If I do the limit as n goes to infinity, that gives me 0. It's not geometric. The only other test I know at this point is integral. So I'm going to set up an integral. And I know it's going to be improper, so I'm going to go ahead and do this. Mary has already reminded us that that integrates to give me inverse tan. So that's inverse tan of b minus inverse tan of 1. So as b approaches infinity, pi halves, yep, pi halves, minus, where's tangent 1? Thank you. Pi fourths. Are you finished? Thank you. Minus pi fourths. And so the answer to that is pi fourths. So what can I say? The series from n equals 1 to infinity of 1 over n squared plus 1 converges. Does it converge to pi fourths? No. No!
Okay, why does the inverse
Converted out of rate.
Why is the inverse tangent infinity? Oh, that's right.
Think about the graph is probably the easiest way to think about it.
So it doesn't converge to pi fourths, but it converges out of regular pi fourths or something like that?
No, it just, all I know at this point is since the area, right, the area between this curve and the x-axis from 1 to b is pi fourths. Okay, the limit as it approaches b. So that means that the curve is approaching the x-axis at a fast enough rate that y essentially becomes 0. So there's no longer any numbers to add to the series. So I can say that the series converges. Hang on one second, Josh. Yes, sir?
Oh, I was gonna wait for you to finish. You
Oh,
finish,
that's
I'm not
okay.
in a rush.
Okay, you can ask me.
Okay, sorry. No, I was just gonna say, the one bottleneck that we have,
Oh, yeah.
okay, is in the basketball office now.
What happens
Because I
if
had all small ones
you
on there.
have a
And so we
series
switched
and
the
Okay.
bottoms on there, and I don't know if you had new ones that you wanted to switch out.
the 4. We already did that. I'll go through the, and I'm not able to balls off in my card, so I can put a card in the practice.
Like, my guns that are on diverges.
We're not. Right, so we should. there should be-
No, it's wrong.
this.
Yeah, I know it's wrong.
You did it in second year, you did it
Yeah, I just wanted to tell you so you can find it.
But then you have to
You got a plan,
I got a
okay?
plan. Thank
And,
you
but,
very
but
much.
Zeb's gonna hit put all bottoms on it. So that's what you want. And there should be 12 or 13.
Okay, and I'll put spelling.
I do have to.
Thank you.
All right,
Appreciate it.
Oh, yeah. I set the gym up, or we set the gym up. And then You must, y'all played volleyball this morning, you want to pass it?
No, Charles.
Charles. His name is Charles.
Okay, since the high force number does not matter at all, and if that was really complicated.
Did you see that?
At all.
Do we
It
necessarily,
matters, it matters.
do we necessarily need to actually get the number the integral goes to if we know it goes to a number? I know it's always better to get a number, but it feels like extremely complicated or something.
But you could, well, because remember, you don't have to simplify.
You don't know.
So like you could leave it as pi halves minus pi fourths,
Okay.
right? And if it was something more complicated, you could leave all those nasty fractions if you wanted to,
Just
as
leave
long as, yep, you're okay. You just provide the proof when you provide the answer.
That's
Okay. Alright, I need to give you some homework.
Can you also, after you're done with that, check your test grade?
So your homework is gonna be homework 9.3, 1 through 17, odd. Okay? And I'm giving you the worksheet, okay? No, I'm gonna give you the worksheet. I am also going to give you, we are going to be we're working out of another textbook. I'm plagiarizing like nobody's business currently. So, we are going to be working out of this textbook of which I'm plagiarizing for the next several days. And so I plagiarized some more and ran off all their answers. Okay, so like you have the answers to the odds in this little packet. Okay, so here's the homework, here's the answers. So you'll just have to look for 9.3 in.
Your plagiarization is not admitting that you plagiarized.
Or that if it's helping someone's education, it should be allowed.
Yeah.
Now we can tell this walk without explaining.
Oh, do not go and tell on me, Emma.
But Sanders said it was okay to plagiarize.
I'll say that next year in college. Plagiarize if it's helping.
No, you cannot say that.
I did not do either of those years, and I did not do.
As always, thank you for your participation. Have a great weekend.
I just get in there and I'm like, what do I do with this number? I don't understand. I'm like,
Yeah, I didn't even